Hello students, welcome to Edubbey Global Solutions. We're going to be looking at another topic which is transformation in a mathematics class, and we have our interactive content that will serve as a guide for this class. Okay, under this topic we are going to be looking at different types of transformation that we have: translation, reflection, enlargement, rotation. Okay, and we have various activities that will serve as a guide for this class. So let's start with transformation itself. Transformation involves taking a pre-image and transforming it into some ways to produce an image. Okay, so when you're talking about transformation, you're trying to take the shape or an image, or you're trying, and then we are transforming it in one way or the other, then to bring another product or another object, which we call an image. Okay, in its simplest form, this change can occur because of reflection, rotation, translation, or enlargement. Okay, so when an object undergo transformation, then its new position or shape is known as what we call that image. Okay, so let's put in the right appropriate letters inside these sentences. Okay, so for transformation to take place, we need what a pre-image, and one of the examples of transformation rather is translation. Okay, so let's check. Now let's look at an illustration here. See, this is for rotation, reflection, we have translation, and we have dilation, or we call it enlargement. Okay, so with that, we're going to start with reflection. Okay, so when an object is reflected, it undergoes a flip movement about a dash or a broken line known as the mirror line. Okay, so when you are talking about reflection, so what really happens in reflection is we call it a flip movement. So on our coordinate values, our x-axis and our y-axis, we can actually flip over the x-axis from the y-axis, and we can flip over the y-axis from the x-axis. And let's note this: when we are flipping over from x-axis to the y-axis, we multiply the y coordinate by 1, right? So we multiply the y coordinate by -1. Then when we are flipping over from the x-axis to the y-axis, we are multiplying the coordinates of x by -1. So from x to y, we multiply y coordinate by -1. Then from y to x, we multiply x coordinates by -1. Okay, so now let's look at this example here. We are to find the equations of this mirror line in the reflection, given the reflection in the diagram we have there. So what we need to do first and foremost is we just have to study how this is being flipped. Okay, so let's assume that we have A, B, okay, C and D here. So if you look at this, on A is what? A is we have A to be on the x-axis, A is 1, and on the y-axis, A is 2. Okay, now let's look at the B. On the x-axis, B is what? B is 2, and okay, on the y-axis, B is what? B is 2 on the y-axis, and on the x-axis, B is what? B is 7. Okay, so now let's look at the C. So on the x-axis, what is C? C is 3 on the x-axis. Okay, and on the y-axis, C is what? C is 6. Okay, now let's look at D. Okay, on the y-axis, D is 6, and on the x-axis, D is what? D is 7, and that is the transformation of that. I think this is a parallelogram, right? That's a parallelogram. Okay, since we are flipping over the x-axis, this is what we are saying. We are moving from here to this place. We are flipping over the x-axis. Then we have to multiply the y coordinates by what? By -1. So if we have that, then this given translation will now turn to 1. By the time you multiply this one by -1, then turn y-axis to be -2. Then for this one, I think we have 8 and 2, right? We have B on x-axis is what? I think B on the x-axis is 7. So by the time you multiply this with minus 1, we have it to be minus 2. Okay, we are multiplying this one to by minus 1, that is going to be 3, then we have minus 6. Okay, now D as well, we are multiplying our y-axis with what? With minus 1, then we have 7 and what? And minus 6. Now let's study the first one. So if you are flipping over, then A here is going to be 1 on the x-axis and minus 2 on the y-axis. So this point here is A. Okay, B now is going to be 7 on the x-axis, okay, and minus 2 on the y-axis. So this is point B. C is going to be 3 on the x-axis, look at it, and minus 6 on the y-axis. So this is C. And D is going to be what? D is going to be 7 on the x-axis and minus 6 on the y-axis, and this is D. And that is the flipping point. So based on this, you see that we don't have any specific equation there. We say that the equation is equal to what? Is equal to y equals 0. And that gives us the reflection of this parallelogram shape on the y-axis. Okay, so now let's look at reflection. If you look at, let's study this reflection that we have here. We look at this shape, we have it we have this right angle, then we flip it over and we have, by the time we multiply our y-axis is going to be changing as well, like we have done. It's going to be changing by multiplying by minus 1. So after we are through, then we have a mirror line in between, just to tell us the line in between the two given right angle triangle. And if you can read through the boxes, you see that we have an equal boxes for this given reflection shape. Okay, now we want to look at rotation. Rotation means turning an object about a fixed point without changing its size or shape. So when you are trying to rotate, the size of that given object will not change, and the shape as well will not change. Okay, so when an object is rotated, it undergoes a turning movement about what? About a specific point. Okay, and that specific point, we call it center of rotation. So look at what we have here. This is an object. By the time we rotate, and under rotation, we can rotate 90 degrees. You know, remember our quadrant line. When we have our coordinate of y and x-axis, let's quickly draw that. This is, so we call this one quadrant 1, we call this is 3, we call it 2, and we call this quadrant 4. So on this one, this is 90 degrees. By the time it moves here, that is 180 degrees. By the time it comes here, that is what? 270 degrees. By the time you move here, that is 360 degrees. And this movement here, we call it what? Clockwise direction. Okay, and if you have a counterclockwise direction, that we are moving from Q2 to Q3, then to Q4, then we are moving back to Q1. We call that clockwise direction. Okay, and that is when we are finding rotation of any given transformation. So now let's look at this translation here. We are looking at translation here. Now under translation, what we mean is that we are trying to move all the points in the same direction and at the same amount in the same direction. So if we are moving any given point, we are moving it in the same direction, and we are moving it with the same words at the same amount. So we are not adding or subtracting from the specific point. Now we have an illustration here. Now an object is translated, it undergo what? A straight line slide movement. So if you are translating an object, you translate it using a straight slide movement. And note, if you are moving from the right downward, then we are to add our x-axis, then we subtract our y-axis. That is the point on the y-axis. Okay, so for something like this, and on the x-axis we are subtracting. That on the y-axis we are subtracting rather, and on the x-axis we are adding. Okay, that is if you are moving from the right then downward. Then if you are moving from the left to the down, okay, that is the left on y-axis, then down on x-axis. Then we are subtracting the x-axis and we are subtracting the y-axis. That is what we do under translation. Okay, so the next thing here we want to look at enlargement. When you're talking about enlargement, it involves expanding and contrasting an object without changing the shape or the orientation of that object, but what the sizes changes. So we can have something that is smaller before them. By the time we are trying the enlargement, then we increase it to be more bigger. Or we have something that is bigger, we have an object that is bigger before, then by the time we are doing enlargement, we reduce it to be something smaller. So the size changes, but the shape does not change. So something like we have a right angle triangle, it still remains what? It remains a right angle triangle. So two pieces of information are needed when describing what? Describing enlargement. That is the position of the center of enlargement and the scale factor of enlargement. So position of the center of that enlargement and the scale factor of enlargement must be put into consideration when we are trying to enlarge any given object. Okay, so now let's look at what we have here. Look at this structure here. In this diagram below, we have triangle ABC, and this is the smaller one. This is the small object, triangle ABC. Then we enlarge it to give us what? Triangle A prime, B prime, and C prime. So we have to calculate the center of enlargement, and then we calculate the scale factor, because those are the points needed when we are trying to enlarge. So let's look at this structure here. Now what do we need to do? We are looking for let's look for the scale factor of AB and A prime, B prime. So if you count the boxes that we have here, let's count one. Okay, we have 1, 2, 3, 4, 5, 6. Okay, so for the AB, the scale factor of alignment is 6. And now for the A prime, B prime, that is the line AB, okay, we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Okay, so we have B prime, C prime. So we have the line A to be what? To be 12. So if you want to calculate the scale factor of alignment, what we need to do is we divide the new transformation, that is the new alignment, which is A prime, B prime, C prime, divided by the length of ABC. So the length AB that we are calculating here is 6 centimeter or 6. Okay, let's use centimeter then. The length AB prime here we have 12 centimeters. So it's going to be 12 divided by what? Divided by 6. And how many times can 12 goes in 6? That is what? That is 2. Okay, now if you want to look at the center of alignment, what we need to do is that we have to draw a proper line, a straight line that will meet every point in this given alignment. Okay, so if you are drawing a sketch, you must draw a sketch that will meet point A straight line that will meet point A together with point A prime, a straight line that will meet B together with B prime. Okay, a straight line that will meet C together with C prime. So wherever those points, the line that you drew meet is what we call the center of alignment. So the center of this alignment here, we refer to it as, look at it, A meets A prime, C meets C prime, and B meets B prime. So that is the center of alignment. So let's quickly put the right answer into the process and let's see. So we have 12 here, okay? 12 divided, that is for A prime, B prime. 12 divided by AB, that is line AB, is what? Divided by 6 is 2. And that gives us that solution to the scale factor of that alignment. Okay? Now, we are looking at negative alignment. When you are trying to deal with negative alignment, each point, its image on the negative or center of what? Of the opposite side. So for a negative alignment, each point of the image are on the negative center of the what? Of the opposite side. Okay, so for a negative alignment, you see that it's just like you're having something that is larger and you are trying to reduce it to something that is what? That is smaller. Okay, now we have a past question here. Let's study this past question together. It is, if you look at it, it's just the translation, because we are not rotating, okay, and we are not reflecting, and we are not enlarging. It's not coming bigger. And when you're talking about rotation, though, the shape will turn around, so we are not rotating because we don't have any center of origin here, which is 0. Okay, now let's look at this structure. We want to study it. They have already plotted the two. They have translated A to B. But what do we need to do? We need to calculate. They said that we should describe the single transformation with map flag A onto flag B. So let's study this. Let's assume that we have this to be point A, point B, and point C. Okay, so for point point A is 5. A, we start with that. On y-axis, A is what? A is 5. And on x-axis, A is what? A is -2. Okay. Now for B, that we are still dealing with flag mark A. Okay. So for B, what is B? Y is 4. Okay. And x is -4. Okay. So now, if you look at that, let's look at point C. Point C. Okay. Y is 5. Y is 5 and x is what? X is -4. That is for flag A. So now let's look at flag B. We have A equals to, let's state it as point A, point C, and point B as well. So for point A, okay, if you look at it, x is 5, y is what? Y is -1. Okay. Now for point B, okay, x is what? X is 3 and y is -1. And for point C, what is x? For point C, okay, for point B, x is 3, y is -2 and not 1. Okay. Now for point C, x is what? X is 3, y is what? -1. So with this, we are going to, I want to study, since we are flipping over to the right and we are flipping downward, that is from the left we are flipping over to the right downward, then based on the rule I've made mention of earlier, then we are going to be adding up our x-axis and we are going to be subtracting what? The y-axis. So now what we need to look at here is that what is the value on the x-axis that by the time you add up, okay, will give us this value. On the y-axis, by the time you subtract, will give us this value. So let's look at it. This is -2. What value do you think that by the time you add up, will give us 5? And by the time you subtract 5 from will give us -1. So, and that is going to give us the translation vector. Okay. So if you look at this, by the time you add +7 to this, -6 to this, add +7 to B here, -6 to B here. So we can call this A prime, B prime, and C prime. That is a new translating object. Okay. And let's add +7 to this rather, and -6 to this place. So -2 plus 7. -2 plus 7 will give us what? To give us 5. That is for A prime. 5 minus 6 will give us what? -1. Okay. Now for B, -4 plus 7 will give us 3 for B prime, and 4 minus 6 will give us -2. Okay. Then -4 plus 7 will give us 3 for C prime. Then 5 minus 6 will give us -1 for C prime. So we cannot say that the translating vector for this given transformation is what? 7 minus 6. And that gives us the solution to the question. This takes us to the end of our class. We want you to subscribe to our channel www.edubbey.com for the full interactive content of this class.